Good afternoon. So we'll just ask you for a few minutes. We are connecting our speaker. Peter Veit is connected from Austria. And when he's with us, we'll start the session. So give us 2-3 minutes, we should be able to start. Thank you. Okay, good afternoon. So we are starting this session. So this is day 3 of the Asian Pacific Transport Forum afternoon session on a very specific topic. So we're going to talk about railways, but from the angle of rail asset management. And this is a topic that is of high interest for ADB, but more importantly for members. And I think you will agree with that. So we are on a partnership on this particular topic with the government of Austria and the Technical University of Graz in Austria. Partnership started 7 or 8 years ago. They are very well advanced on this topic, and the partnership is providing support to most of our member countries developing new railway projects or maybe also improving existing system. So we like to go for the most advanced knowledge and practice, and the Technical University of Graz is really at the forehead of all this innovation, and also the very solid methodology, and ultimately it is about providing better service, whether it's freight and logistic or passenger, but also optimizing the cost. And we are talking not just about the capex, but also the operation cost, and so that we make sure that we provide the best service over time. So this partnership has been ongoing. This session is 90 minutes, so it's short. There are many things we can say about this topic. So I would see it as a teaser and a very condensed form of the 1-week training and workshop that ADB in partnership with the government of Austria provides. It's every year. Last edition was in September. We'll have a short video. I see in a room some of you have participated in the workshop, so maybe we'll hear from you and your experience and the learning. This type of workshop, we see it as a learning experience, but as a joint learning experience. So when I say joint, is for ADB colleagues as much as our government officials and delegates participating. And we try to have the discussion evolving around the actual issues that you're facing on the new project. And the way this workshop is designed is that there is all this learning session, but also very specific project description. The good thing is that for this training, we are among professionals. So you have a lot of knowledge, you know your networks, you know all these difficulties. You've been working in the sector for an entire career, and that brings knowledge to the room. So it's not just one way coming from the professors, but we are all learning together and ultimately trying to develop a better project. So that's a beautiful spirit, and I think it's something that started a few years ago. And this approach we have also replicated on other subsectors for transport. So we do it for urban mobility, road safety, road asset management as well. So really working together. So the delegates, the ADB team, and the trainers, just trying to improve things in our countries. So that would be the introduction to this session. So we have two speakers for this workshop. First speaker is Satomi Sakaguchi. She's an ADB colleague, transport specialist, and she will give you an overview of how ADB supports the railway sector and the kind of assistance we'd like to, and we are able to provide you. So that would be the first part. So you've heard many things already, but in 10 minutes you will be able to summarize, take a project example as well. And in the second part, we have Professor Peter Veit, who will join us online. Remotely was not able to come to Manila, so from Australia. And he will give you a condensed form and try to explain the thing and the key takeaways from this workshop, long version, 1 week training that I mentioned earlier. And then we'll have time for discussion, for your question. But what I would like you to keep in mind is that this is a very short form. What we would like is to continue the discussion. I think some of you have already been part of it, but also for you to know that we have this training offering. And beyond the training offering, the professors from the university, Technical University of Graz, can do some country-specific work with you. So it has been the case in Georgia and Azerbaijan. We are talking about it for Bangladesh this year. So that's in this context. So short, brief, teaser style in a good way, but really would like to show you the foundation of the partnership, how we approach things, and how we would like to be able to work with you. So with that, Satomi, I'll invite you to the podium.
Good afternoon. Hi, it is a true privilege for me to speak in front of all of you at the Transport Forum 2024. I hope you have enjoyed the forum so far. And thank you, Bertrand, for introduction. My name is Satomi Sakaguchi, transport specialist from the Railway Logistics team inside the Transport Sector Office. Our Railway Logistics team was created out of the organizational reform of ADB in June last year. You may have heard about it in the previous sessions. And under our director, we have 15 colleagues working on rail projects across ADB's development member countries. Today, I'd like to briefly present ADB's assistance, specifically in this railway subsector. So you may have seen the similar pie chart many times this week. But before we go into railway subsector, I'd like to briefly highlight that our entire transport sector portfolio has gone through a significant transformation in the last decade. So as you can see from the left to right, the road subsector was the sector where our assistances were predominantly focused. Now we have more assistances in rail and urban transport. In particular, urban, which includes rail-based mass transit services project, which has really increased its share, almost doubled in the last decades. So this big shift reflects emerging changes and priorities in the transport sector in general. And in some respect, these priorities are corresponding to changes, and also of those changes, I'd like to mention a couple of them. For example, so the population and behavior patterns changes. So more and more of the population in the Asia and Pacific now live in cities, and also poverty ratio has lowered. This has led to increased demand in urban mobility that is well integrated and also inclusive to all types of users. And advanced or various technologies has been a major influence also. Digitization and automation has been observed in every area of our lives, including the transport planning, design, implementation, and operation and maintenance. And of course, climate change, the need to mitigate and adapt to huge impact of climate change has been the most dramatic change in our lives. And faced with those challenges, the priority in the transport sectors have been affected by various policies, agreements, and conventions. ADB itself published its Sustainable Transport Initiative Operation Plan in 2010, which while recognizing the continuous need for road investments, also advised on strong focus on urban and rail subsectors. And United Nations Sustainable Development Goals has also included several transport-related goals, including those related to rail subsectors. And of course, in 2018, we have published ADB Strategy 2030, which have summarized all those changes and directed our focus for next 10 years. Of those, probably climate change, a shift regarding climate change is the most critical. Especially we look at when we look at the transport sector contribution to the CO2 emissions, which is 23% of the global CO2 emissions from the older industries. And the increase in the last decade from 2010 to 20 of this amount by about 35% is also significant. And of this total the transport sector CO2 emissions, road subsector accounts for almost 75%. So therefore, we have realized that all of us working at the transport sector have the collective responsibility in moving towards cleaner transport mode, such as railways and metros. But while, of course, continuing with decarbonizing other sectors, including road sector as well. So those priorities and changes mirrored by our ongoing project, our current portfolio across our member countries. So sorry, the letters are a bit too small. But for example, in South Asia, we have 7 projects, India, Bangladesh, and Sri Lanka, in railways and metro, all of them quite a large investment, and the 4 projects ongoing in Central West regions. And here in the Philippines, we have, of course, Malolos Crack Railway Project and South Commuter Rail Project. And in Bangkok, this is a non-sovereign private sector investment, but we have assisted Bangkok Mass Rapid Transit Project. So from some of them, I'd like to mention more specifically the important, the highlighted projects. So we have assisted the Delhi Meerut Regional Rapid Transit Systems Investment Project. You may have heard about this project from the executing agency of this project in the first day's session. But this is truly a flagship project for ADB. It is kind of a new modality in India, semi-high-speed rail commuter transit, connecting Delhi to various other cities in the surrounding region over the 82-kilometer corridor. So this is part of the big network, and we are assisting first line at the moment. And next one, we also in India, we have assisted Chennai Metro Rail Investment Project, which is another big, huge project. It will run in mostly urban parts of the Chennai city, which is the 4th biggest city in terms of population in India. So the large part of the line will be underground. So very difficult construction. And we are also assisting the transit-oriented development and some of the stations. And in Bangladesh, we've been assisting Sussex Chattogram Cox's Bazar Railway project. This is also a big project connecting Dhaka to very important city, connecting Chattogram to very important tourist destination, Cox's Bazar. And important element of this project is that we have incorporated particular project for conserving wildlife such as elephant. On the first day, if you have joined the session for railways for decarbonized transport, you may have seen the elephant overpasses and elephant sensors to protect the elephants from touching the railway. So yeah, this is another one. And lastly, but not of course least, this Malolos Crack Railway project. This is, you will all know, you may already have known this project very well, but connecting Metro Manila with the suburban cities up north of Crack. So it's a long commuter rail transit and providing connectivity from this very dense urban area of Manila and the suburban area, therefore helping dispersing population and economic activities concentrating here to other areas outside Manila. So, yeah. So these are the ongoing projects, but moving forward, for what will direct our future assistances. So we have identified 3 key priorities now. So one is integrated transport systems. Of course, we've been trying to achieve integrated transport systems, but here we mean integration in all ways, in all kind of ways. So for example, we will more and more focus on multimodal solutions. So when we are assisting, say, railway project, we will also focus on connectivity with road and inland waterway. So this will be more and more emphasized. And we will also emphasize filling in critical missing links in regional connectivity, trans-border connectivity, and also, importantly, more probably quite related to asset management, today's topic, we will try to provide more integrated assistance from policy to downstream projects. So, so in this way, we try to make assistance integrated in all areas, physically and also in non-physical manner. And the second is improved access. We want to make sure that transport mobility is available and it is safe, reliable, and affordable to passengers of varied incomes, varied needs, and removing any physical and non-physical barriers to movement. Again, in achieving this target, this goal, this vision, asset management will play the key role because reliability will be very much affected by the appropriate asset management planning and implementation, as Professor Baitz will talk about in the next session. And also, finally, of course, reducing negative externalities, especially climate and disaster challenges. So these 3 will be the focus, the area of our future assistances. And again, I think we need to focus a little bit on the climate change related efforts. So traditionally, last 5 years, the transport sector of ADB has been contributing 24 to 55% of the total ADB climate financing. However, ADB has set a target of climate financing until up to 2030 of $80 billion US. And for this goal to be achieved, transport sector has to contribute constantly 25% in the climate financing. For meeting this sector level target, we need to strengthen policy, strategy, institutional support, not just investment support, And we need to expand our partnership with private sector, and knowledge capacity development for low carbon and climate resilient transport will be also improved. So with these goals, we are now preparing our pipeline for next 3 years, and I hope this will be a very exciting aspirational one. So in the South Asia, we are currently preparing 5 projects, 3 metro projects and 1 railway project. We are working with the government of Bangladesh for developing fast MRT network in one of the most congested urbanized cities in the world, and Dhaka Mass Rapid Transit Development Project, Line 5. And we are also assisting the second corridor of the RLTS project in Delhi, India, and 2 metro projects, which are not in India's 4 biggest cities, but outside those cities. So urbanization has really reached to that stage. So we are expanding our support in urban transport to those second-tier cities in India. And in the Central West Asia, we are assisting the overall railway sector reform project in Georgia. And coming back to Southeast Asia, Philippines, well, this must be very familiar new project already, Manila Metro Rail Transit Line 4 project, which will be running very close to ADB. We are preparing this project. And also in Jakarta, we are assisting MRT project, East-West connectivity. So yeah, we hope to achieve all these projects in time, and yeah, continue our efforts in achieving cleaner transport. Okay. So I finish here. Sorry, I probably overran the time allocated, but thank you so much for your patience, and yeah, thank you.
Thank you, Satomi, and such a wonderful overview in just a brief 10 minutes, giving us the magnitude of the challenges, but also the project that are ongoing, and maybe more importantly under preparation. Integrated system, improve accessibility, reduced external impacts. So in all the discussion we've been having, we are putting the services, the passenger, the logistic first. Not talking much about infrastructure, but now we are going to talk about infrastructure because it's needed. To provide service, we need good infrastructure. And we have with us Peter Veit, is the head of the Institute of Railway Engineering and Transport Economy at the Graz University of Technology in Austria. So he will give us this presentation and overview on the technical aspect from the rail asset management perspective, overall trying to optimize both cost and services provided. Before giving the virtual floor to Peter, we have a very short video that was done in September 2023 in Graz during the last workshop. So that would just give you a flavor of how these things are done. And maybe for those who have not participated yet, maybe it will give you some, maybe the extra push and try to join and participate in the next edition. The training is an opportunity to learn, that is number one. But more importantly, take action on what has been learned to make sure we can deliver the best possible railway system and solutions to support the shift to railways and low emission modes for passengers and goods in the region.
My name is Peter Veit. I'm head of the Institute of Railway Engineering and Transport Economics of Graz University of Technology. We have a close cooperation with ADB in the field of infrastructure, especially dealing with asset management, as we see the importance of asset management for a sustainable railway.
Hello, this is Sadia Afroz. I'm from Bangladesh, working with Bangladesh Relay.
Hello, colleagues. I'm Evgeny Novosatov from Ministry of Transport of Republic of Uzbekistan.
Hi, I am Dagiwa K. Kodala from the Philippines. I'm currently working with the state-owned railway company, which is the Philippine National Railways.
I am Nusrat Chaudhary, Associate Project Analyst, Bangladesh Resident Mission, ADB.
Спасибо, здравствуйте. Я пришел...
So, hello everyone, my name is Askar Hadjiyev and I came from Turkmenistan and I am a chief engineer of the railways in Turkmenistan.
I am Prabu Setio. I'm from MRT Jakarta, Indonesia.
I'm expecting from this training that I'll be able to learn about the correlation between the economic analysis and technology we are applying, and also it will work for our future investment project. And I'm very much glad that we have other participants from other countries, and there will be a big learning session from the other participants. Thank you.
Okay, so now it's time to welcome Peter. We'll see you on the screen shortly, I guess. Peter, can you hear me?
Yes, thanks. Hello, everybody. I can hear you.
Okay, welcome.
Can you give me so I can you hit the screen?
We can see you. We hear you loud and clear, and we see your screen, so you're ready.
You are seeing my screen.
Yes.
Yes, perfect. And you see now the screen in the full scale.
Yeah, we see your inbox.
So you see
Not your
the
slide yet.
yeah, you see the slide with the title, and you see the second slide as well. So it works.
No, we cannot see the slide yet.
You cannot see the slide yet. Okay. And now?
Now we can. Please,
Now
Peter.
we can, and you see the second page as well.
Yeah,
So
so now if you shift to full screen mode, you will be ready and good to go.
I shift already.
So maybe there is a lapse.
Wait a little bit. I will do it's the second time.
So we did all the technical check last week.
Yes.
It's working perfectly.
It was working perfectly as normal.
Okay, you're ready. Peter, please.
You see it now.
Yeah.
And you see the further slides as well.
Yeah.
Yeah. Okay. So thank you very much. Thanks for the film at the beginning, because a lot of was already mentioned. I want to show today why asset management is that important in infrastructure, in railway infrastructure. Of course, the one thing is to build something, to invest into something. But the second point is to keep this in a proper status. So to do the best maintenance, the necessary maintenance, which is important for making value out of the investment money. And I want to highlight these links, these things which are together with with technology and costs. So what's the specifics we will speak about? Railway is a quite complex structure. but it is nevertheless one system. We have extremely long service lives, which is necessary. We use timetables, which is a big difference to other transport modes. And unfortunately, if you hear the word railway, the word expensive is very close. And railways are a strange system. They accept nearly everything. On the other hand, they can be very capricious. Both these railways, if you see these two films in parallel, you see that there is a wide range of different types of railways. And you see, let's say, very poor quality on the left-hand side and a very nice quality on the right-hand side. The right-hand side is the film of the world record run of the French in 2007. What is the difference? It's both railways. The one has a very, very poor quality, which results in very low speeds. The highest quality only enables high speeds. So when we speak about railway infrastructure, we have to speak about quality. And quality must not be in between, quality must be very much on the high level. A sustainable railway system needs high quality. However, that does not mean that in every country high speed is the proper solution. That very much depends on topography and on the structure of settlements. But from the technical point, anyhow, we need high system quality to be sustainable and to be economic efficient. And I will show these today. What can we do? What is the progress in superstructure? We use heavier track, concrete sleepers, the bigger rail profiles, higher rail steel grades. Our track is continuously welded using long rails at the beginning. So these rails are delivered from the factory in a length of 60 or 120 meters. And our track is continuously laid. So not section by, not 25 meter, but continuously. We use under sleeper beds. We use subsoil rehabilitation because the system railway, the system infrastructure is not just the superstructure. It is also the substructure. And we have mechanized the maintenance in a very high degree, which allows high quality with modern maintenance machineries. The target is high quality. This allows to have little track deterioration. As soon as we have little deterioration, we have long service lives. And as soon as we have long service life, our system can be economic efficiently and thus sustainable. What was the system railway on its way in different fields? The one field was high speed, and it was a remarkable world record in 1955 to run 331 kilometers an hour. Unfortunately, look at this track. This track was used by one train run only. It was the world record run, and after this world record, track was gone. In 2007, they ran 574.8 kilometers an hour, also on ballasted track, and the track didn't even feel it. So after the world record run, the line was just opened for normal traffic. What was the difference? What is the reason for that? That was mechanization. So we can say we can run fast. This requirement we can fulfill. But look, this is a very old timetable. It's already from the year 2000. And this is a high-speed timetable from a high-speed line. High speed means little tolerances because we cannot accept high dynamic forces. So we have maintenance demand. look, this timetable is just 1 hour. There is one thing for sure, there's no time kept for maintenance. So in a high-speed line, you can do some maintenance in the night. But we have we have a problem to get availability and maintainability together. The other end of our targets is heavy haul. Heavy haul is working. In Australia, the Rio Tinto runs 24-ton axle load, does energy recuperation, and this is a fully automated train operation. I was also impressed by Southern Africa. The iron ore line in the Republic of South Africa has standard with 7-kilometer long trains. High axle loads, fast track deterioration, high maintenance demand. Again, you have the problem with to have the system maintainable and available in the same. Europe, we have mixed traffic, not just Europe, but also Europe has mixed traffic situation. In Austria, you may think it's beautiful because we do not run very high speed. We run 230 maximum, and we do not run heavy haul. We run 22.5 ton axle loads. But we run passenger and freight trains in the same time, more freight trains in the night, more passenger trains during day. But our network is 5,000 kilometers of main network, but we run more than 6,000 trains a day. That means we again have a problem because whenever we go for maintenance, we disturb operation. We do not have operation-free time. I spoke about sustainability. We need sustainability, but what is sustainability? There is a technical sustainability. There are some examples. These are the cart routes in Malta. They are 6,000 years old. Nobody knows what they were for. This was a Roman road, the Via Appia, north of Rome. This was a Roman water line transporting water over this bridge. And this was Cloaca Maxima, so that is a wastewater line. This is not the sustainable which we are looking for, because we do not need a technical sustainability only, we need an operational sustainability. This, we do not know what for. The Via Appia is not used as a road anymore. And the bridge for the water, the aqueduct would work, but on the left and the right end of the bridge, there's nothing kept. But the solution in Rome with the wastewater, this is still in operation. So let's say more than 2,000 years. So we are looking for operational sustainability. And we want to look for the best solution. And I put a very extreme example. When you build a house or a building, it is normally cheaper to paint the walls than to cover it with materials. Of course, is it always like this? This is the famous Piazza Navona in Rome. It has special colors, and they must be reused because there's tradition, that's UNESCO, and so on. Unfortunately, these colors for these buildings are watercolors. So you have to paint all the buildings every 3 years. On another example, in Portugal, in Lisboa, they put these materials outside because they have so much salt in the air that the normal material would fall down. This made a tradition. Now that's the famous azulejos, and they are still in use. So in this very specific case, the right-hand solution is cheaper than the left-hand solution. That means which solution is the best depends only on the boundary condition. And it's not always the same result. We need to have a specific sustainability for the specific given situation, and that's asset management. So asset management needs to answer just 3 questions. Which components should be used under which boundary condition? They will differ. If you build a motorway, you will use other components comparing to build a road, a little road in a forest. And that's the same true for railways. When we can define which components we should best use for the given situation, we have a kind of investment strategy. The second question is how to maintain these components, and with maintaining the components, to maintain the entire track. This answer would lead to a maintenance strategy. And finally, there's a third question. How long is it useful to use this system? What is the useful service life? This is the question of efficiency, and this is an economic question. So just 3 questions to be answered, and that altogether is asset management. However, you cannot answer these questions separately. You cannot decide on an investment strategy not knowing what the different components need in maintenance demand. You must never make a decision only on the investment costs. You always have to look on the total cost. So you need maintenance. That means investment strategy for its own cannot exist. You cannot decide on a maintenance strategy not knowing what was the investment. So maintenance strategy cannot exist. Much more, there is just one track or one infrastructure strategy. And the useful service life is an economic consequence of both of investment and maintenance. So these all 3 questions go into one. There's one basic principle of all economic evaluations, which is very, very simple. And this principle is we have to consider all cost consequences of a decision. So when we do an investment decision, we have to know all the consequences of this investment. That gives the question, how long does an investment lead to costs in the system? And of course, every component leads to costs as long as it is in the track. So asset management needs to be life cycle management. Only in that view you can give a total answer for the best, for the technically and economically best solution. Asset management must be life cycle management. So that's to consider all cost consequences over the time axis, but there is also something further. Infrastructure causes costs. We are working, we are maintaining, and so on. These costs are normally paid by the infrastructure company or infrastructure department, however the railway is organized. But there are further costs which are caused by these track work. And these are costs which occur at the rail operator, at the operators. Because when some machines are on the track, the trains cannot go, they will be hindered. They will have to use another route, or they will be substituted by buses, and so or they are simply delayed. And all these things also lead to costs, and they need to be taken into consideration as well. So in fact, when we are working on track, we have a capacity reduction, which gives delays. Delays gives, if you have it very frequently, the market doesn't like it so much, so we have a reduction of market, of customers, and we have additional costs of operation. And then there are follow-up delays and problems with shunting and rerouting trains and rail transport replaced by buses. And all this together lead to costs which we call costs of operational hindrances, and more penalizing of delays is coming into that as well. So this can be calculated with a little bit work because it's depending on lines and train types, but these are relevant costs to be considered in asset management for the infrastructure as well. So that's the system we are working in. And now we are looking for the best, the most economic, the most efficient, and thus the most sustainable track. Unfortunately, this cannot exist. Much more, there are many best, many economic, many efficient, and many types of sustainable tracks. Many because there are so many different boundary conditions. You would take another solution if you have a high loaded line in a sharp curve, or if you have a high loaded line in a straight section. So there are many best tracks, different for the different boundary conditions. And it's the task of asset management to identify these specific solutions for all the relevant boundary conditions, which leads normally to a multi-component strategies. Seen over the time, we started with maintenance with repair of failure, then it came time-based, condition-based. Now we go to predictive maintenance. Next is to add, which these two steps go together, we add the investment, and then we are not just in maintenance, we are in asset management. And that is the development which you could see in every country over the time. Mainly we are here towards predictive maintenance. And what's the new, what's the important on predictive maintenance? If we want to predict something, we must be able to go for forecasts. So we have to analyze how track will be in future to answer the question, when will we have to intervene? And when we add investment and see it as a total system over the entire service life, then we are at life cycle management. Forecasting, that's the headline. For forecasting, we need either experience or data. We started more experience-driven. Now, digitalization and so on, we are more on the data side. These data needs to be analyzed, it needs to be put into time sequences. So the data itself is not the most important. It's how these data change over time. That's time sequences. This both is possible. And then we have to analyze it. There I see some more demand. This is a very, and finally, which is also on the way now, this asset management, so the life cycle management, is the life cycle assessment, which is taking the ecological effects into the evaluation, is on the way. Fail and fix, very simple. You run the car until there's no petrol in it. Do and prevent, you go frequently to all petrol stations. Monitor and prevent, you could look how much is still in and you can make better decision. Predict and prevent, you even can calculate how long you can go on. And this is the same with railways. Take the head checks. What was the first about head checks? We learned that they are dangerous, and we learned it by a bad accident in the UK. So we had to prevent this, and therefore they went on grinding. And no hedgehogs could become any more critical, but unfortunately we ground away our rails. And then let's find the reasons. Let's fix the reasons. Don't go, we need not to go to grind everywhere. Look where it comes, how long it takes, how it is related to transport load and things like this. And then we can measure and we can predict and we can make a maintenance solution for this. This is one of the examples. So what I want to speak is, or what I believe is life cycle management. We have to understand our assets in technology and in costs. When we want to understand our assets in technology, we need to understand how the quality changes. So we need to understand the quality behavior, and we need to understand the relevant costs. Quality behavior is the technical, life cycle cost is the economically understanding of asset behavior. And this together is life cycle management. More concentrated, of course, more work is necessary in the quality behavior, but we need also the life cycle costing. And nowadays, the ecological footprint is taken into consideration as well. Life cycle management thus is technology, economy, and data science, data and experience. And we have tools, data analysis, simulations, big data, digital twins, artificial intelligence, and whatsoever. Technology needs to ensure that the system is functioning, it works. It doesn't make sense to do any economic evaluation on a system which doesn't work. The economy pictures the functional system in payment flows to identify the most efficient solution, so to make the strategy final. But boundary condition specific. Nowadays, it's simple because there are so many tools. Big data is one of them. Put all the data you have into a pot, boil the pot, and the wisdom will jump out. Unfortunately, it's not like this. We did an example and asked the system, what is which track has the least deterioration over time? And we put in all track we have and all this information about deterioration, and then big data calculated, and the answer was the heaviest, the best track has the most deterioration. So this answer is obviously wrong. But there was nothing wrongly done with the calculations. The tools show numerical relationships, regardless of whether these relationships are real or coincident. So the tools are tools. That means the thinking keeps at us. The thinking is not done by the tools. And that's the same for artificial intelligence. What else can we learn out of this? We must do the analysis parameter specific. Why this result came up? The best track, the heaviest track has the biggest deterioration. Yeah, of course, because we use the best track, the heaviest track, if we have a lot of traffic. So if we answer what is the best track, it's wrong. If you answer what is the best solution for a certain traffic load, a certain radii, a subsoil, and so on, then we will get proper answers. So all analysis must be parameter specific. Knowing these parameters and their effects is the key knowledge regarding infrastructure. Then we can go for life cycle management. So we have to speak about knowledge, about data. Let's start with the data. There are different possibilities. Vehicle to measures infrastructure, infrastructure measures vehicle. So all the possibilities. I will focus on the most used system. Vehicle measures infrastructure, a recording car does some measurements, and that gives data and data and data. And what do we do with the data? We put it into clouds. And then We think that the wisdom and the knowledge will rain down from this clouds. And that will not happen. Collecting data is a precondition for asset management, but it is not sufficient. And often I saw the situation that a lot of data were collected, and then there were, pardon me the bad words, these data were stored away, far away from decision-making, not to disturb the decision-making. We want to do the other way around. We want to base our decisions on data. So we have to think how we can come from data to knowledge. Unfortunately, again, the way from data to knowledge, this direct way does not exist. It is a cascade of different steps which you have to go through to come from data to knowledge. First of all is data verification. This must be the first point, because as soon as the data are stored anywhere, you lose some information and you cannot verify it later on. Verification must be first. A very stupid, simple example, you have a mirror and you see, does this mirror show a precise picture? The figure is identified, perfect. The contour fits, perfect. The size is scalable, okay. And even you see the soil is shown precisely. Wonderful, a good data picture. But when I'm playing chess, I want to know if the figure is the figure of my, is my figure or the figure of the other one. So this data set is not usable. When we have verified the data, then we can store it. And before storing, we have to do another step, and that's synchronization and positioning. Synchronization is now, in one recording card, there are many measurement systems. Synchronization is normally done automatically by the recording card, because when the recording card starts, these different measurement systems do not start in the same way, so they have a shift. But this you can program once and then it works. The more problem is the repositioning of different recording cards, because the recording card needs to know where it is. So therefore we have GPS or DGPS. Yes, that's some meters preciseness which we can get. We can combine this with fixed points on track, and then this system would work proper for track, but not proper for turnouts, for example. Now, these are raw signals. Every color is another recording card, and this is a quite good recording card. But this, with this data, you cannot do any analysis, because you cannot identify how it changed from the one recording current to the next, because the data are obviously shifted one another. They are not in the same position. So you have to reposition it. This gives some work. And after repositioning, the same data would look like this. And now you see, okay, in that place, it became worse, slowly, and then faster, and so on. That means for analyzing, for analyzing the degradation, you need to reposition the data. And there is a second point which you have to take into concern when you go for turnouts. In turnouts, you have so many inspection data. The people go there, do some measurements. They are relevant measurements because they are safety relevant. But however, these measurements are unloaded measurements. There was no drain there. So unloaded measurement. And if I see a turnout and it is not loaded, it won't do anything. It won't run away. It still is there. This is no information which you can use for forecasting. When a train comes, the rails in the turnout start to move and so on. This is information which you can use for predicting, because at the new rail turnout, the movements in the turnout will be little and they will grow when the turnout gets older. So you need loaded measurements for prediction. Doing this, we can go for time sequences. And now we are in the old system. We have one information about track quality. This is the red point, and the red line is the threshold. So should we go for maintenance, or can we wait further on? We simply don't know it. Whenever we go to analyze time sequences, we know how it was before. And now we get an impression. On the left-hand side, it deteriorates fast. You need, sometime you will need maintenance. On the right-hand side, you will have longer time. And if we go from that, looking to the past into a forecasting, we can even calculate in which point of time do you have to intervene. That's the step from condition-based to predictive maintenance. So we are looking, this is a recording car data over a certain length. Something was measured. The dark is poor quality, the green and the light yellow is good quality. And we look it over time. And we see it deteriorates, of course, and we got this formula. And this is valid for everywhere. So that's strange, as long as it's dynamically loaded. And that's strange, because we have so many different boundary conditions, we have so many different tracks, but we have one behavior. And this behavior is telling us that the quality in any point in time depends on the initial quality, and then it deteriorates with a certain rate of deterioration over time. And this is not linear, this is exponential. That's simply the reason due to the reason of dynamics. But that means initial quality is quite important. And the deterioration is quite important to define maintenance. Initial quality is defined by investment. This is checked for more than one networks in Europe and time sequences of 22 years. This formula, I think, is quite important. Initial quality is given by investment, and the maintenance is fighting the exponential deterioration. Please keep in mind, investment delivers quality, but not service life. If you build a beautiful track, you expect to get high service life, but in fact, you only construct high quality, which is very important, but high quality is not service life. There must be something to transpose the high quality into service life, and that's maintenance. Maintenance is the action which transposes quality into service life, and therefore maintenance is thus important. You can build the best track ever, the best project ever, and then you don't have money for maintenance, and all the economic efficiency of the investment is gone. If you don't do maintenance, the service life would be reduced down to less than 50%. And then it cannot be efficient anymore. So we need this trend analysis. We have forecasting, and forecasting is only possible as we understand track, and that's the knowledge which is keys out of data. One economic result, which I think is quite important, we always calculate the dynamic annual average costs, so over the entire service life. And now we look, how are these costs, what is the composition of these costs? So 100% is the total cost of track. The biggest portion is depreciation. investment per service life. On a high loaded line, this is a line with 150 trains a day, maintenance and cost of operational hindrances are in about the same. But they are roughly 20% and up to 55 to 60% is depreciation. That means there's only one possible strategy for asset management in railway infrastructure. Go for high service lives. Increase the service life. This will be sustainable. This is only possible if the system is technically sustainable, and that will lead to an economic sustainability as well. Service life, we have to look shortly on the service life itself. What's service life? Here you see the yellow curve, that's the deterioration function. Then we come to a level of a threshold level, intervention threshold. We do some maintenance, we come up with the quality again, it goes down and so on and so on. There's natural wear as well, so we never can go to the initial quality from the new track. Of course, an old track cannot have the same quality as a total new track. This is the technical service life because here you cannot maintain it to a proper quality anymore. The useful service life will be shorter because here we have so much maintenance that this will not be sensible to execute it. Then there is another service life, that's the bookkeeper service life, and please, bookkeeper service life must not be taken as a decision tool for deciding track work. Decision on track work is always for a specific section, as it is parameter specific. Bookkeeper service life is always an average value, so it cannot fit. What is important to know, how long should be the useful service life? And this is important because service life directly goes into depreciation, and that's the biggest cost portion. So we have to think about that, and it's quite simple. The function of costs of depreciation over service life is investment per service life. That is this one, a very simple function. Of course, if you have once decided the service life, the depreciation will be constant. But when we are looking for the service life, it is this function. This would mean take the longest service life possible. But there is another cost function, and that's maintenance. And the maintenance will increase over time. And if you add together, you have total cost of ownership, you look for the minimum, and you know what is the best point in time for going for reinvestment. If you go for reinvestment earlier, you throw away assets. You throw away values of the asset. If you go in too late, you already did too much maintenance, and which is also not efficient. So this is the graph which I already showed, and now some examples to see how the system reacts. There is a very simple solution to prolong service life in doing nothing. The track will deteriorate, and then you run into a threshold value and then a problem. But if you reduce the speed of the trains, you reduce the dynamic forces, and you can reduce your threshold value, and you can go on. So you don't do a lot of maintenance, you just reduce the train speed. And this is reducing the depreciation, but the cost of operational hindrances, all the trains are delayed and so on, are very high. This is the most costly situation, and this is strictly not accepted in Europe in the main networks. We could go for maintenance reduction, because maintenance reduction is so nice because this money keeps in the pocket. But maintenance is just 20%, so you have to reduce it in a big scale that you feel it, that you feel savings. And if you do this, the consequence will be that the service life will be shortened and depreciation will go up. It's no solution as well. But this also exists. A total reduction of all type of costs, and that's the typical picture of an innovation. And this special figure with the 68%, so 1/3 cost reduction, was the result of one innovation which we implemented in the since 2009, and that was under sleeper pads. But it's always to look at over the total time. So what is the present research? We do prediction. We have area of confidence. Of course, we want to get this area of confidence narrower. To narrow that, that means we should put quality of maintenance into it. This will work in future with fiber optic sensing. Quality indexes, better quality indices by digitalization. We equipped one damper with a lot of sensors, and which allow us to calculate the energy input by damping. And of course, if the ballast is polluted, you need more energy to move something in it. And that we turn around, and we can, by damping, we can analyze the pollution of the ballast early, very early. Now you know that the ballast is polluted as soon as the mud is coming up. We could give this ballast pollution in an early stage. This is finally worked out. Now it needs to be filled with data to be able to define threshold values. That's still under research. We want to specify the loading. Now, normally it's always the annual tons or the daily tons, but the tons are coming from the rolling stock, and there is different rolling stock. We have a model to put that into the consideration, which would allow us to calculate how much maintenance and service life would change if we change our rolling stock. And this should be an important input for the decision on which rolling stock should we take. Of course, this gives some formulas, but it is already implemented. For example, in Switzerland, they do their track access charging based on that. So if a rolling stock is track friendly, it pays less fee than another one. And now, today's and mainly future challenges. When we can go for prediction, we can calculate how much reinvestment will be necessary in the future. If we put in the same track always, everything is constant, this will be something like this. That there are some ups and downs, that's only because of history. We calculated it when we implement all the innovations which we have and which are already in implementation, but not in all the network, then the demand of reinvestment would shrink because the innovations target to have longer service life, and therefore you would reduce reinvestment demand. But when we think on additional traffic, this will eat up the benefits. That does not mean that we should not do the investments, the innovations. We need to do the innovation because we are in a vicious cycle. It is a race between optimization, which we can do by lifecycle management, including all innovations, with the increasing transport load. And that's the research demand for future. Traffic increases, maintenance demand increases, track possessions will shrink because there are more trains there. We do not get access to the track so easily. If track possessions shrinks and traffic increases, the units of costs of maintenance will increase. The cost of operational hindrances will increase because whenever we close the track for maintenance, we hinder more trains because there are more trains. And that's the same for reinvestment. And this is the reason why the budgets will increase. If transport increases, the budget for maintenance must increase to keep the system sustainable. This is nothing new. It was always in history of railways, it was like this. However, we saw more traffic, we did any innovation, we did more maintenance. The time for this track work was there. Now we are on the corner. We have more demand, but we don't have more time for doing the necessary track work. And this means we need more innovation and faster implementation and optimization by lifecycle management. And to finish up with a short summary, there's nothing more expensive than short-term savings. Whenever you do short-term savings, track will accept it, and it will not react badly now, but it will react in future. And whenever track will react on short-term savings, the service life is already gone. You reduce maintenance for the next 10 years, then you see you get problems in track, but then you cannot solve that problem with more maintenance, because most likely already the service life is gone and you need to go for reinvestment. So short-term savings lead to very high costs in future. And there is nothing more efficient within railway infrastructure than quality, because quality will reduce the maintenance demand, not the executed maintenance, the maintenance demand, and will increase service life. Reducing costs of infrastructure in a sustainable way requires investing into quality. There is no other solution possible. Read that sentence. The bitterness of poor quality remains long after the sweetness of low price is forgotten. This sentence is older than railways, because this sentence was by Benjamin Franklin, the US president in 17 whatsoever. But it fits quite good to our situation. But what's the reason that sustainability is such a sustainable problem within railways? It's not the budget, it's the short-term savings. The short-term savings have one nice solution. You do some short-term savings, so you have a good network, good quality, everything is nice. You want to reduce costs, you reduce maintenance, and at the end of the year, the quality is still good. So you did a proper thing. So next year, you will go on further reducing the maintenance. And this will work for some years. So some years, some money will keep in the pocket. But then the cost will explode. And then you cannot do anything against that. Then either your system goes down in any quality, in speed, in axle load, or you have to handle big, much bigger budgets. And that's why these short-term savings are comfortable. And the other way around is true for high quality. When you want to install high quality, in order to reduce your total costs sustainably, you have to invest some little money into this additional quality that you can go that way for sustainability. I already spoke about this undersleeper bed, what we implemented. In economic figures, it was tremendous. The investment was increased by 5%, just 5%. The outcome was 40% reduction of maintenance and 25% increasing service life. That was the most efficient innovation I know. And we have to go the way for quality and sustainability. This is the target, and lifecycle management is the way to do it. Thank you very much for listening.
Thank you, Peter. Asset management needs to be life cycle management. It could not be any clearer. And thank you for this introduction to the program. A lot of substance, and I think it's a great summary of the program, because the 1 week program goes deeper into every aspect that you covered. Now we have time for questions, if we have questions from the audience. Yes, sir, there is a microphone, so I will ask you to introduce yourself before asking the question, please.
Hello, good afternoon. I'm Loy Gawili from Forest Holdings. I'm the chairman of the corporation. In this discussion of the railways, the best quality is always the German. So if you get a German trains, it will be very expensive. Now, Hitachi was used for the London train. Japanese costs are always cheaper than that of the German. So, but for the Philippine setting, wherein the cost is always the is most important, we go either for the Chinese or for the Korean technology. Now, normally, like for example, the Philippine experience, we're using the Korean technology for these railway projects. Does this mean that the quality of the Koreans is not as good as that of the Germans? Now, another question is your formula. Is it universal? Does it work for all the technologies, for the different train systems? Alstom has its own technology. TGV has its own technology. Hitachi has its own technology. Does it work? Is it the same? Thank you, sir.
Yeah, thank you for the question. Peter, before you respond, so ADB is an institution, so we are neutral in terms of manufacturer, and the way we see it is that we encourage competition. So it's nice that we have many different manufacturers in the landscape that can compete, and of course, as you said, there are some difference. But Peter, I would like to hear your reaction to this.
Yeah, there is one sidestep first. You are right, DB has a beautiful quality. Unfortunately, this was true 20 years back. The quality of the DB network is down. It's one of the poorest qualities which we have in Europe now. How could they manage it? In reducing maintenance, in doing nearly no maintenance for the last 20 years. And now the network is very, very poor. In technology, I think in Europe, in infrastructure technology, Austria is first, Swiss is second, then all the others, and then German railway. From the research and the technology, these countries are German railways, French and Austrian, they are good. From operation, I think Swiss is the best. You cannot afford the costs which are in Europe. Yes, but you won't have the costs of Europe, because the technology, the costs sum up from material costs, machinery costs, and labor costs. And the material costs are slightly different. So you have slightly reduced material costs. You have more or less the same machine costs, but you have very much reduced labor costs. So that won't be the same cost level in all the countries. Even in Switzerland, we have another cost level than in Austria. And even just in Europe, we have a difference in labor costs from 1 to 10. So it is about the technology, the quality coming out of the technology. It's not about the country, the costs of a country. That's not the, you can create a proper quality for your system. And if you're an Asian, and if it's the Korean high speed, then it's a very high quality necessary. And if it's something else, you can put the proper quality. That's what I wanted to express. You don't need to have the best track ever. You need to have the best suitable track for your situation. And the costs are not the same like in Europe. You cannot take these figures just. And that's coming to the second question. Can you use these things universal? Yes, in the point of technology, in the way how track reacts, in the way how it works. Why does this track behave differently to the other one? What is the reason? What are the parameters? This is the same. This is valid all over the world. Perhaps you have to adjust some parameters a little bit. If you go to the former Soviet countries, they have another gauge. Of course, you can calculate that in. If you go to South Asia, you won't have the parameter deep freezing in winter, of course. But the main parameters will keep the same, and you can use the knowledge about the behavior related to these parameters and create your system. In this regard, it is working. The economic results you cannot take from another country because the cost levels are that different that something which might be very economic in the one country can be not that economic in another country. So you can use all the technical information, all the reasons for track degradation, all the ideas for service lives. You adapt it slightly for your specific parameters. You will have a certain traffic load. You will have a certain radii and things like this. You will have a certain quality of subsoil. You take these parameters, put together to your typical track. This you can do mainly based on discussing and adapting the existing technologies and the existing knowledge. That will work. But as soon as it comes to the economic results, you have to recalculate it with your own cost figures. They are differing too much.
Thank you, Peter, for the very detailed answer. Do we have more questions from the audience? Yes, please.
Okay, thank you for your presentation. I am a Mongolia Resident Mission Transport Staff, and my question is very simple. Are there any existing developed railway asset management software or maybe simulating like kind of the softwares? And if it is, could you please just shortly provide some features of this kind of the software?
Yeah, what I spoke about is of course implemented and not just theory from a university. We implemented, we built up this theory together with railway companies, of course, in the first line with the Austrian ones, then it was Switzerland, then it was some other Europeans and mainly in the third step, it was Scandinavia and then some other European and Eastern European countries to implement these methodology, how to do asset management. This is something which is a kind of methodology which is, this is existing and you can use this methodology. The adaptation to your parameters, to your specific parameters needs some work, but in principle, these tools are existing, but they are not fully simulations. They are programs. Then you have some adaptations. Then you have some parts which are programmed again. So it's more an expert system than a full simulation. But this expert system is implemented, is working, and can be used.
Thank you, Peter. Yes, please.
Thank you for your presentation. My question is a little bit more. The first one is the data collection and asset management.
Excuse me, sir. Could you please introduce yourself so that everyone
Oh,
in the
I am
room
MD Abdul Wahab, Project Director of MRT Line 5 South from Bangladesh. So my question is this, the data and also the asset management. So you have said clearly, so the data management may be wrong. So basing on that, I may plan for 6 set of courses for my operation, but later on I find the data collection is wrong. So I need 8 set of metro. So instead of 8 set, I have started 6 sets, so asset management may be better. But if later on find, if it is 8 set, at that time, the expansion of that requires a lot of effort, maybe suspension of operation is there. So what is your suggestion? Should I go at the outset for the earlier asset management more, or we may have risk taking less asset management, maybe wrong data, so later on we can increase, and how much time it may take to conversion from here to there? I think I could make myself clear. Thank you, sir.
Yes, yes. That's an important question. And the best is to have long time sequences of data, of proven data. And of course, this is a conflict in itself. You want to have a modern measuring system, but if you change the basics of the measuring system, the time sequences won't work anymore. So, but there is another possibility. And the other possibility, if you do not have enough data, you will have some data which are measured anywhere, which are relevant, which are necessary. When we started with this implementation of lifecycle management, that was in the late 90s in Austria. We did not have that many data, and we did not have the time sequences as we got a new recording car in 2000. So we could build the time sequences only from 2000 onwards. But we did not wait until 2005 or 2010 to have time sequences, but because we had experiences. The people know what happens. The people know why this section is a more problematic one than the other. And from that, we could formulate typical, we call it standard elements. So typical situations for the track, how does it behave at that load, at that radii, on that superstructure, and so on. And in the same moment, we started to do the time sequences. So the measuring, the putting it's analysis is another step. The first step is to have the data and to put it into proper time sequences, repositioning and all these things. We did this in parallel, and time by time, we could switch from more experience-driven to more data-driven. Now we are mainly data-driven, but we still need experience because there are some information which never will be in the central data because they are so unique. So I think you can start with lifecycle management. I would not wait. You can start with lifecycle management in using the experiences of your railway staff and of course of the foreign examples, because a lot of countries worked out such type of standard elements. This was not just only in Europe, this is also in Georgia or in Azerbaijan and so on. So this gives you an idea. This is will not deliver totally precise results, but it gives you the direction where you have to go in your asset management system. And as the time goes by and you get more data, you can specify it more and do the fine-tuning of your model. but you can start it with only few data and experience and foreign experience, and all this together to create such standard elements which form then the base for your asset management system. The main decisions for which components to use and these main decisions will be stable. If you should go a little bit more maintenance or a little less, this you need more data, but the main decisions you can do on experience and using foreign experience and your own experience. And this was the starting point which we always had, also had. And we did not need to change our results from the experience with the data. They always showed it is in a proper area. Of course, the fine-tuning was necessary.
Thank you. Thank you, Peter. We can take one more question. Okay. So I think that brings the session to a close. Peter and Satomi, thank you very much. And please join me in thanking our eminent speakers.
Thank you.
And if you would like to continue the conversation with Peter, the next edition of the training in Graz and workshop will be in a year's time. So we follow the usual process called for nomination. And for those who are already interested, we can interact with the professors from the Technical University even before the training. As we mentioned, there is this 1-week workshop that gives the fundamental of the approach, but Professor Veit and his colleague Stefan Marschning are also working with some countries to do some and to help national railways to do some specific analysis on this topic. So that's what we call phase 2. So you also know your ADB focal person for this project. You can also reach out to us, but there are many, many things we can do in that field. So we'll be happy to work with you. Thank you again. And I think coffee again is served outside if you need a shot of caffeine. That would be a good time for that. Peter, thank you very much.
Thanks.
It's been a pleasure always. Please have a beautiful day. I hope it's a wonderful springtime in Graz.
Beautiful, it rains.
Okay. Auf Wiedersehen. Thank you. Thank you, everyone. Bye.
Thanks. Bye.